So the name of our project is, well, the fancy name is streamlining the implementation of muscle simulation for use on skin deformation. And so basically what that means is that we want to simulate human muscles on a rig ready for animation. And now this is kind of weird because when you look at the skeleton on the screen, this is what people usually use to animate a human character or biped. And as you notice, they're just sticks. And so when you deform, you'll lose the shape of like the elbow, or you just won't keep the shape of like the muscles that a model has already modeled. And so what we're trying to do is fake reality. As you can see on the screen, there's an image of a crash test dummy. We're not gonna crash anything, but it's the same basic concept. We're doing something that's fake to try and simulate something in reality. And as you can see, the human body has a lot of muscles though, so that's a lot of ground to cover. And how are you supposed to do that in a character for animation? How are you supposed to get the quads and the pecs and the biceps? How are you supposed to make sure that they deform correctly? There's a lot of ground to cover, and well over 100 muscles. Well, this has been a problem for a long time. This has been a problem since the 80s, and people have submitted many papers to SIGGRAPH with different solutions, and they usually revolve around things called influence objects or blend shapes. In this case on the screen, this would be considered an influence object of something that deforms when you bend the arm, and it will push out the mesh where you've painted influences or where it's been determined influence would happen. And now there are other solutions too, because around up here in the upper torso, there's a lot of problems with rotations because you're not rotating in one direction, you're rotating in multiple directions. And so people have thought of other ways to correct them. In this case would be a point cloud of data showing particular problem areas and then using those to calculate the adjusted meshes. In this case, on the screen, this is another method which would be kind of like using a cloth simulation. I don't know how many of you used cloth in Maya before, but it basically turns all the vertices and uses gravity to try to simulate cloth. And it does this over an entire muscle system set up to deform. And that takes a long time to set up. Another method, like I mentioned earlier, is blend shapes, which is a series of predetermined deformations that you can use sliders to adjust towards. This isn't actually a simulation, though. This is more or less just a slider and can cause complications for different areas where you have more than one rotation or more than one muscle might be deforming. As I've said before, there is cloth simulations. If you can see, there's a lot of settings for cloth. And it's really hard to set up, takes forever to calculate, and it just doesn't always give you the results that you're looking for. So our solution is to use something that Autodesk Maya has recently released in the past few years called Maya Muscle, which essentially is similar to a cloth simulation but also uses influence objects in a way, like this right here on the screen is actually a sample of a Maya Muscle using an actual rendered image. This isn't what the Maya Muscle looks like inside of the program. This is what a render looks like. But this is essentially what it does. You create the shapes, and those influence the mesh, but you're not overlapping the mesh and having it drop on it like a cloth. Now, for our simulation and testing, these are the characters that we modeled for the purpose of testing. We have a female model and a male model just to show that this can work for any biped. And we have them T-pose here just to kind of show off how we're going to set up the rig for when we're running the simulations. To start off, they're going to be skinned, and the muscle simulation is going to be set up on the T-pose. The characters are already textured. It's kind of hard to see on these screens, actually. We're not going for anything too fancy because this isn't an art project. But just to have the functionality and have the correct muscle shapes and scaling, this is a real-world proportioned human. Now, on our scripting side, as opposed to, well, the more technical side as opposed to the art side, is very lengthy. This is just the positioning for the bicep, just the bicep. We still have the positioning for all the other muscles in the body, as well as what actually drives the system and creates the muscle rig automatically for you. And this is the interface that we created for the user to use. It's very simple. You click a button, it opens up the screen, and then you've got all the different controls to place the locators for where the joints will be placed. You've got the global scale, which will increase everything in size to the same proportion. And then as it goes down, you've got placement of your joints. You can place your muscles. You can adjust individual muscles. This is a sample showing just of the locators before the joints are created on our muscle simulation. Sorry, I'm going through this really fast, but there's a lot to talk about. The locators can be placed individually. It doesn't have to be globally scaled, and the joints will be placed. And it doesn't matter how far apart they are. The muscles are calculated based on the length of the distance between the two different locators. As you can see, in this case, we have them matched up for the arms. You can see all the muscles are placed, and all their shapes have been determined. They're placed automatically by the script that we created, which is almost over 4,000 lines of code by this point. It's set up like a normal rig, and it has all the controls that you'll need for animation. It will be animation ready. I'm just showing a few poses that we put it in here. So you can see some of the deformation is happening. And we can also change the amount of deformation that these do. This is also not supposed to replace the process of creating muscle simulations either for animation. This is to hasten the process, so it still allows the freedom of the user to go into individual muscles and adjust their endpoints specifically for whatever shape the character might be, including like the lengths of the arms are different. If they have slightly longer arms and legs, this is all determined, will be pre-calculated by the script, and then can be gone in and adjusted specifically by the user for different characters. This can be tailored individually. And every muscle moves, and will have jiggle effect as well to simulate the move, like for flailing, and will deform as you can see here. Right here, the muscle is a little small because the deformation setting is actually on low right now, but this is what it looks like on low. The bicep is clearly larger on the right than it is on the left. It is a little zoomed in on the right as well, but you can see that the shape has changed and it is much bigger. Now, going into the future, we also need to try and figure out a solution for painting the influence of the muscles onto the skin mesh. Right now, it's determined by the location of the vertexes. So that limits us because every character is different. We cannot create an umbrella solution for everything. So coming out of this class, we hope to someday figure out a solution for that. But right now, this is what we have, and we're ready for testing next week. Or this week.